Hello everyone, I am Sweetie Pinjani. Today we are going to see one very interesting construct which is used in Verilog and system Verilog force release. First we'll understand what this construct does, then we'll understand the applications and see a coding example. Let's understand this construct, force release. First we'll understand what force does. What force does is whenever you use it on net, register or variable, whatever drivers it will have, all those will be overridden with the forced value. And then when you release it, that value will be released. Here is an interesting twist. Release works differently for net, register, variable. Let's understand how. For the register and variable, once you release, the value will be held until the next assignment happens. Say for example, I have a register and I forced it to the value 3. Register will retain that 3 value until it gets the next assignment. In case of net, what will happen? It will retain the previous value. Say for example, before force, the net had value 2. After force, it had value 3. So after force, the value became 3. And when you released, that 3 value got released and it went to the previous value, which was 2. This happens in case of net. It goes to the previous value. Now let's understand some applications. There can be a lot of applications of force release. I am listing some major ones and I'll give you example of each application for you to understand. First is in design debugs. Say for example, you were debugging a design and in waveforms you notice that enable signal is 0. You suspect that if the enable signal is 1, the design will work properly. Now to completely ensure that whatever you are suspecting is true, simple thing you can do is just force enable signal to 1, rerun the test and see if the design is working properly. If after forcing to 1 your design worked properly, it means whatever you are suspecting is correct. And somewhere in the design, enable should be 1 but it became 0. But at least you have identified the cause of the problem. This is one simple example I gave you for design debugs. There can be many such cases. I'm just giving you one simple example. The second is to verify the connections. Now, inside our SOC, there will be a lot of connections. There will be some sources, destinations. Say I have a 32-bit data, which is going from source to destination. What I will do, I will force the 32-bit data, of course, to a non-zero value and see if it went to the destination. This is how I can verify the connection. Then large counters. This is one very interesting example. Let me explain you. Say you have a 64-bit counter. Now 64-bit counter will have how many states? 2 raised to 64, which is a very large number. It will take billions of cycles to reach that state. I don't have that much time. So what I will do, I will force my counter to the value which is nearest to 2 raised to 64 so that I don't have to wait too long. It will reach 2 raised to 64 and after that if I want to check, say it again reset to 0. So I can do it easily using force. No need to wait for billions of cycles. This is one very important application of force release. Another is coverage improvement. We are going to come up with the coverage series soon. For now, I'll give you simple example. See, in code coverage, we have a toggle coverage. What that toggle coverage does, it will check whether 0 value was covered, 1 value was covered, transition from 0 to 1 was covered, transition from 1 to 0 was covered. Now, there are thousands of signals in your design. It may be difficult to cover all the values even if you run the test multiple times. Because of this, your toggle coverage will get impacted. So what you can do to improve your toggle coverage, you can force your signals to particular value, run the test so that you exercise that values and also improve your toggle coverage. This is one another important application. Now what we will do, we will see a coding example. Let's see a coding example of force release. Now let's see a coding example of force release. I have taken 2-bit register and 2-bit wire. Wire is getting assigned the value 2 in the continuous assignment statement assign. And register we are assigning in the initial block. In the another initial block, we are displaying whatever the values were assigned. We are forcing register to 3, displaying, forcing wire to 3, displaying, releasing register, displaying, releasing wire, displaying. Then we are assigning register another value and display. Let's see the output. First, we are just displaying the values which were assigned. Wire was assigned 2 in assign and register was assigned value 1 in initial. We are getting those values. Then we had force register to 3. We are getting that value and wire is retaining its value. We had forced wire to 3. That is also coming. Then we have released register. One thing you have to notice, we had seen this, even if you are releasing the register, it will hold the value until the next assignment happens. That's why even after releasing, you are seeing register is having 3. But when you release the wire, it will go back to the previous value. Here you see that when you are releasing wire, it no more contains value 3. It contains the previous value which was 2. That's how it should happen. Then when you assign register another value, it will go to that new value. This is how force release works. I hope you understood the concept of force release, and I do hope you are finding all this content useful. I'm always open to feedback. You can give your feedback in the comment section. I, Sweetie Pinjani, will see you soon with another video tutorial. Thank you.